This is 3.1, day 1. Today we're going to focus on exponential functions and their graphs. On Monday, we're going to cover the base E of exponential functions. That'll be our day 2. Kind of help guide you what I do want you to write down and what I don't want you to write down. And today's assignment is from the smartboard. It will not be in your textbooks today, so you're getting a little warning about that. Okay, first slide, I just pulled this from an IB textbook. I'd say you probably don't need to write them down if you don't want to, just kind of reviewing the power rules and how you simplify with powers. So I'm just going to pick the B's to do. So you're going to kind of help me through it. So question B, what would you do first to reduce that exponential? What would be the first thing we do? Think about your PEMDAS rules. Cube what? Yep, cube -3. So I have -3 times -3 times -3, which is -27. And then what do we do? Just multiply the negative, yep. And you get positive 27. Let's do question B. Let's reduce those two exponentials. So we have 6xy to the 5th over 9x squared y to the 5th. What do I do with that fraction now? What do I reduce? X to the what? Yep, so we can cancel the y's, because I have a y to the 5th and the y to the 5th in both the numerator and denominator. And then my x's, how many x's can I cancel out? I can cancel one x out, okay. What about my coefficients? Reduce it by 3, good. So this now becomes a 2, this becomes a 3. So we're left with a 2 in the numerator and then a 3x in the denominator. Let's go to the next one. 16 divided by 2 to the -3. So right now I have it looking like this. What do I do with the negative powers? Flip it up, right? Remember that from algebra 2? We flip it up. Now makes it a positive 2 to the 3rd. Now 2 to the 3rd represents 2 times 2 times 2, which is 8. And then someone help me with the calculator. 128, okay. All right, last one to review. A, B to the -1. What do you do there when you have a negative power? Flip it again. Put it down, yep. So now it's 1 over B to the positive 1 power. Then if we distribute that 1 power, it's still just 1 over A, B. So we're just kind of reviewing a little bit of our power rules. Are you doing logarithms in this chapter? Yes, not today though. Logarithms are the inverses of the exponentials. Okay, this is a very important graph for you to do write down in your notes. It's a exponential function of y equals 2 raised to the x power, where 2 represents the base and x represents the power, or the exponent. So we've done a little bit of work for you by finding all of the ordered pairs. How we found these ordered pairs in this box is evaluating the function. So if I substitute 0 in for x, 2 raised to the 0 power is, anything raised to the 0 power is 1. This is our critical point right here, 0, 1. It is also the y-intercept, yes. And then if we evaluate the function for 1, so 2 to the 1 power is 2. So that ordered pair, that is over 1 up 2. Then we evaluate the function for 2. So we sub in 2. 2 to the second is 4. So our order pair now is 2, 4. Then 2 to the third is 8. That order pair is right here. What causes some difficulty with some students is when we go into the negative integers and evaluate those. Remember that last slide. If I say 2 to the negative 1, what would you do with 2 to the negative 1? What do we do with negative powers? Put it on the bottom. So it would be 1 over 2 to the 1, which is 1/2. So now that's this point here. Negative 1, and then 1/2. And then 2 to the negative 2 power is 1 over 2 squared, which is 1/4. And the last one, 2 to the negative 3 power would be 1 over 2 cubed, or 1/8. When you describe an exponential function, it starts off pretty slow, and then it starts to gain some speed, and it starts to increase at a very fast rate. So the graph looks like this. It increases over time. So if I asked you for the next order pair, what would be the next order pair? 4, 4 to the second would be 16. 2 to the fifth would be 32. Then there's some other pieces that we're going to identify in this graph. The domain. What type of numbers can you plug in for x? What can you evaluate for x? Are there any restrictions on x? Can we plug any number in if we wanted to? Sure, we could. Most students tend not to write, plug in fractions. So the domain would be all real numbers, or another way to write all real numbers is negative infinity to infinity. The range. What type of numbers are plugging in, but what do we get out after we plug those in? Are there anything that's going on with the y values that are restricting that? Is there an asymptote in this graph? Yep. There is an asymptote as this curve goes in the negative direction. There's an asymptote right here. It's a horizontal asymptote at y equals 0. So for your range then, are there order pairs falling below that horizontal asymptote? No, the graph is not existing below that horizontal asymptote. So the range would then be what? Numbers greater than 0, so it would be y greater than 0. How about x-intercepts? Does it touch on the x-axis? Does it touch on the x-axis? No. It will never cross the x-axis. So that is a none or no. What about the y-intercept? Is there a y-intercept? 0, 1. Right here. Very important number. We tend to focus on the y-intercept, or the critical point would be this. So when we take care of transformations later in this lesson, we're going to focus on that 0, 1. And we already talked about the asymptotes. There's a horizontal asymptote at y equals 0. Does this graph stop at all? Are there any holes in the graph? No, so it's continuous through the entire graph. So from negative infinity to infinity. Is the graph increasing or decreasing over time, over the x values? Is it a positive slope or a negative slope? Positive, so it is also increasing. Yes. So this is some key points to this exponential function. It's kind of like the parent function, a base 2 exponential. As we change the base, we'll talk about what happens to our graphs. We'll talk about when we shift the entire parent function up, if we shift it to the right, if we reflect it. All those transformations that we talked about in the parent functions earlier in this class are coming back again for this lesson. Your next quiz will be non-calculator based again, coming up next Friday. So what we do in class on this lesson is just to kind of help guide you through, but you need to know the transformations on your own in comparison to this graph here. I'm going to stop the recording there.